Hello everybody and welcome to the second part where we look at the JAMB Mathematics Past Question for 2022. Now if you've not watched the first part, in the first part we looked at the first 10 questions, and now in the second part we're going to be looking at the next 10 questions. So if you've not watched the first part, I will encourage you to do that, and also I will encourage you to subscribe because we have the entire tutorial videos that covers the entire topics and for the syllabus, JAMB syllabus for mathematics, so that if there's any topic in particular you're struggling with, you can get clearer explanation on the concepts behind that. Now in this session we're just going to be looking at the next 10 questions for JAMB Mathematics Past Questions for 2022. So let's get started. So the first question says that, or the 11th question says that the 10th term of an AP is 32. Now, if the first term is 3/2, what is the fourth term? Now, if you don't know what an AP is, I will encourage you to watch our tutorial videos on arithmetic progression. So let's get right into solving this. We know that the 10th term can be written as A plus 9 times the common difference, 9D. And we're told that that is what, 32. Now we are also told that the first term A is what, 3/2. Now we are told to find the fourth term. So the first thing we can try to do is to figure out what the common difference is, and we can do this by substituting the value of A as 3/2 in this equation over here. So that becomes 3/2 plus 9D is equals to 32. Right? Yeah, so we know that 9D will be 32 minus 3/2. And to solve this, we know that this is just going to be 30.5 or 30.5. I need to convert this to mixed fraction, or to improper fraction rather. This becomes 61/2. So we just know that if we divide both sides by 9, we know that D will be equals to 61/2. Then we can multiply this by 9, and common difference is just going to be 61/18. But we have not been asked to find the common difference. Instead, we've been asked to find the fourth term. Now we know that our fourth term in arithmetic progression can be written in terms of what, A plus 3D will be our fourth term. Now we know what our first term is and we know what our common difference is, so we can substitute that into the equation. So we know our first term is what, 3/2, then plus 3. We know our common difference is what, 61/18. 61/18. And now we can easily simplify this. We know that 6 will divide 18, I will get 3 by 18, I will get 6. So this is the same thing as saying 3/2 plus what, plus 61/6. You can easily find the LCM of both of that. So 6 divided by 2 is 3. 3 times 3 is 9. 6 divided by 6 is 1. 1 times 61 is 61. And that becomes 9 plus 61, which is 70/6. Now 2 can divide 70, which will give us 35, and 2 divide 6, which will give us 3. So the answer to this is what, 35/3, which is option A. Now moving on to the next question. We are told that tan is positive and sine is negative. In which quadrant does theta lies? So if you remember from our trigonometry lectures, you know that you have to draw the four quadrants. We have 4 quadrants. So we have our first quadrant, our second quadrant, our third quadrant, and our fourth quadrant. Now in our first quadrant, we know that sine theta is positive, cos theta is positive, and tan theta is also positive. Now in our second quadrant, we know that sine theta is positive, cos theta is negative, and tan theta is negative. In our third quadrant, we know that sine theta is negative, cos theta is negative, and tan theta is positive. And in our final quadrant, we know that sine theta is negative, cos theta is positive, and tan theta is negative. So in which of these quadrants, so if tan is positive and sine is negative, so in which of these quadrants do we have sine as negative and tan as positive? Now, if you look carefully, we're going to see that that is only the case in our third quadrant, where you have sine as negative and tan as positive. So the correct answer is what? Our third quadrant, which is third only. So the correct option is option A. If you want more clarification and explanation on this, you can watch our tutorial videos on trigonometry. So now, in how many ways can the letter zoology be arranged? Now, this is a classic permutation problem, looking at the ways in which numbers and words can be arranged. Now, if you remember from that discussion, see that the way to address this is we are going to make use of factorial, but now we're going to count how many letters we have here, which is 1, 2, 3, 4, 5, 6, 7. So we have 7 letters in the word zoology. So this guy is going to be what? 7 factorial. But we're not just going to find 7 factorial. And why is that? Because we have some repeating words. For example, we have the letter O, and O appears here thrice. So we don't want to, and you cannot distinguish between them in the arrangement. So we have to divide them by the repeating letter. So in this case, we have the letter O that is repeated 3 times. So we divide it by 3 factorial. Let's say there was another letter that appeared more than once also. We're going to divide it by the number of times it appears factorial. But in this case, O is the only letter that reoccurs. So we can now simplify that. Now we know that 7 factorial is the same thing as writing 7 times 6 times 5 times 4 times 3 factorial, right? Then we have over 3 factorial, over 3 factorial. Now this 3 factorial can cancel out this 3 factorial, and we're left with 7 times 6 times 5 times 4, and that is 814. So in other words, there are 840 ways in which the letter zoology can be arranged, and the answer is option C. So moving on to question 14. We're told to find the integral of 2x plus 1 raised to the power 3. Now, this is a very interesting thing to solve. So we're told to integrate. We're told to integrate 2x plus 1 raised to the power 3 dx. Now this might look complicated, and it sure does look complicated, but the first thing we need to do is to try to simplify this. So what if you can simplify 2x plus 1 as a letter u? So we can say let u be equals to 2x plus 1. Simple enough, right? So now we can write this integral as integral of u cube dx, but we cannot integrate u with respect to x, so we need to find what dx is in terms of u. So if we differentiate this expression over here, we know that what du over dx is going to be equals to what? 2, because when we differentiate 2x with respect to x, we get 2, and this becomes 0, so there's no point writing it. So to find dx, or to make dx a better formula, we know that if we cross multiply, we know that 2 dx will be equals to du, and if we divide both sides by 2, we know that what dx will be equals to what? We know that dx will be equals to du over 2. So we can replace the value of dx as du over 2 in this expression over here. So this becomes the integral of u cube times du then over 2. Now if you recall, when you integrate the integral of any number, for example, the integral of any number, I'm just going to use a with respect to a, for example, will be equals to what? A or a raised by n to the power of, the integral of a raised by n dA will be equals to what? A raised by, we're going to add 1 to the power n plus 1 over n plus 1, then plus our constant of integration. Now this is one of the standard rules of integration, so I'm going to apply that same concept here. So the integration of u cube is just going to be equals to what? U raised to power 3 plus 1 over what? Over 3 plus 1. Then we have this what? Times du, or times, we have this 2 over here because we still have 2 in the base, right? So then plus our constant of what? Integration, c. So this becomes what? U to the power of 4. Then we have 3 plus 1. 3 plus 1 is what? 4. Now 4 times 2 is what? 8 plus c. And what does that become? We can replace back our value of u, which is what? 2x plus 1. So we know that this becomes 2x plus 1 raised to the power of 4 over 8 plus our constant of integration. And what option coincides with that? That is going to be option B. So the correct answer to this is option B. Now, if you want more clarity on differentiation and integration, we also have tutorial videos addressing that topic in particular. So let's move on to the next question, which is classic matrix multiplication. So we're going to multiply this matrix. Now this is a 3 by 2 matrix. So the first matrix A is a 3 by 2 matrix. Is a 3 by 2 matrix. And matrix B is a what? 2 by 2 matrix. Now you can only multiply two matrices if these numbers are the same, and in this case they are, and the result of the multiplication is going to be this times this. So we know that if we multiply these two numbers, we're going to end up with a 3 by 2 matrix. So to start with the multiplication, I'm going to draw a big bracket, 3 by 2 matrix, so we can easily go with that. So we have this, and we're going to start. So the first number that we're going to have over here, we're going to say 2. We're going to multiply the first row by the first column here, and we're going to do that for all the entire cells. So for example, for the first cell, I'm going to multiply 2 by 3. So we have 2 times 3. Then I'm going to add 1 times 4. So plus 1 times 4. Now that is going to be for the first cell. Now for the second one, I'm just going to repeat that same process. So I'm going to have these 2 times these 2 and plus this 1 times this 2. Then that is going to be what? That'll be 2 times 2 plus 1 times 2. And I'm going to repeat the same process. I move on to the next second row over here. So that'll be 2 times 3 plus 3 times 4. So I have 2 times 3 plus 3 times 4. I'm going to do that also for the next cell. Now this is now going to be 2 times 2 plus 3 times 2, which is this 2 times this 2 plus this 3 times this 2. And the next one is going to be 1 times 3 plus this 2 times this 4. So you have 1 times 3 plus 2 times 4, and the final one is going to be this 1 times this 2 plus this 2 times this 2, which will be 1 times 2 plus 2 times 2. And now we are done. So we're going to try to simplify this and see what that gives us. So let's get started. So what is 2 plus 2 times 3? 2 times 3 is 6. Times 3 is 6. And what is 1 times 4? 1 times 4 is 4. So we have 6 plus 4. The next one is going to, what is 2 times 2? Times 2 is 4. And 1 times 2 is 2. Next one is going to be 2 times 3 is 6. And 3 times 4 is 12. Next one is going to be 2 times 2 is 4. And times 2 is 6. And the last one is going to be 1 times 3 is 3. And 2 times 4 is 8. And we have 1 times 2 is 2. And 2 times 2 is 4. So now we have that. So when we simplify this, which is the final step, we have, what is 6 plus 4? We have 10. 4 plus 2, 6. 6 plus 12, 18. 4 plus 6, 10. 8 plus 3, 11. And 2 plus 4, 6. So this means that the correct option is what? Option D. So again, matrix multiplication is very easy, but it can be confusing to know what you're supposed to multiply with what. So if you are struggling with this, I will encourage that you watch our video on matrix multiplication. So let's move on to the next question, question 16, which says we should make V the subset of formula. Now, we've been given that R is equals to the square root of what? Of 3V over pi h. And we're trying to make V the subset of formula. So the first thing we want to do is try to get rid of this square root. And the way we get rid of that is by finding the square of both sides. So if you find the square of both sides, this square cancels out this square root. And we have what? We have R squared is equals to 3V over pi h. Now, if we cross multiply, we have what? 3V is equals to R squared pi h. Now, if you multiply both sides by 3, we have what? V is equals to pi R squared h over what? Over 3. And what option coincides with that? That would be option C. So the correct option, or you make the subset formula, is going to be option C. To learn more about subset of formula, you can watch our videos on subject of formula. So for 17, we are told to find the determinant of the matrix. So you can also watch our video on matrices and determinant to find out how this is gone. But the way you go about solving this problem, since this is a 2 by 2 matrix, is very simple. All you do is just you multiply the diagonals, and by diagonals I mean, for example, you have 2 1 3 3. The diagonals will just be what you have in the diagonal. You multiply them together and you subtract from each other. So in this case, we're just going to have 2 times 3, which is the first diagonal, which is what? 6. And the next diagonal is 1 times 3, which is 3. And what is 6 minus 3? 6 minus 3 is 3. So the determinant of the matrix is D. Now, if you had like a 3 by 3 matrix, finding the determinant is a little bit a more complicated process, but it's more easy. But if you watch our videos on matrices and determinants, you'll be able to easily solve determinants of both 2 by 2 matrices and 3 by 3 matrices. So let's move on to the next question, and this is a classic question on log. I thought to evaluate log 8 root 2 base 2. Now this is pretty easy, and the way we go about this is by trying to convert this to the indices form. So what do I mean by that? So now if you recall, we know that log, we're going to write this out first. Log to base of 2. Now we know that 8 through 2 is the same thing as writing 8 times square root of 2. Now we're going to write these two numbers in terms of 2. So this is the same thing as saying log of base 2. Now we know that 8 is the same thing as writing 2 raised to the power 3. Alright? And we know that square root of 2 is the same thing as writing 2 raised to the power half. Now, if you recall from our law of indices, we know that log 2, we know that when you multiply two numbers that have the same base, it's the same thing as writing just one of the number and summing up their power. So it's the same as writing 2 to the power of what? 3 plus half. And what is 3? And what is 3 plus half? So this is the same thing as saying log 2, then 2 raised to the power 3.5, because 3 plus half is 3.5. Now we can bring this down here, which is the same as what? 3.5 log 2 to base 2. Now we know that if the log and the exponent are the same, that is the same thing as 1. So log 2 base 2 is 1. So this is the same thing as writing 3.5 times 1. And that is what? 3.5. So the correct option to this is option C. So for more explanation on logarithm, you can watch our video, 3 videos on logarithm. So let's move on to the next question, question 19, which says the locus of points equidistance from a fixed point is a dash. Now this just is the use of complicated words to say something that is very simple. Now the locus of points equidistance from a fixed point, it means that if you have a fixed point, let's say this is a fixed point, what is the name of the locus of points if you have equal distance from all those points? So let's say this is the equal distance, equal distance, equal distance, equal distance, equal distance, equal distance, infinitely, and you join all those points together. What is it going to give you? As you can see, the points, the locus of points equidistance from a fixed point is what? Is a circle. And that is why for a circle we have the radius. The radius is always constant. So the radius is equal distance from the center, and when you trace out the radius across the entire degree of the circle, you get what? You get a circle. So this is a simple question, and the answer to that is a circle. So it's not just about memorizing that the locus of points equidistance from a fixed point is a circle, but really understanding what that means. And what it means is that you have the radius in the circle, which is always constant, and when you trace out the locus of point made by the radius, you get a circle by definition. So the answer to this is option A. And now let's move on to the last question in this part. We are told to find the result when the numerator of 96/50 is decreased by 37.5% and its denominator decreased by 20%. Now this is pretty straightforward. So we know that 96/50, right? Now we're going to be decreasing the numerator by 37.5%. So decreasing the numerator is the same thing as saying what? 96 times, when we decrease it by 37, same thing as saying 100, which is the total percentage, minus 37.5%. And for the denominator, we are decreasing by what? 20%, which is the same thing as saying 15 times, this is the same thing, the total is 100 minus 20 what? Percent. So this is just easily just going to be equal to 96 times, what is 100 minus 37.5 times 62.5% over, and what do you have here? 50 times 80%. Now what does this become? We know that 96 times 62.5%, we can write this also, though not necessary, but just for completeness. Now the same as saying 62.5 over 100 over, this is same thing as saying 50 times 80 over 100. Now this 100 cancels out this 100 and we are left with 96 times 62.5. When you punch that in your calculator, you get 6,000. And when you punch 50 times 80 in your calculator, you get 4,000. And this 30 cancels this 30 and I left with 6 over 4, which is 3 over 2. And 3 over 2 is what? 1.5. And 1.5 is option A. So the correct option to that is what? Option A. Now this brings us to the end of the second part of our JAMB Mathematics Past Question for 2022. So if you have any question, or if nothing is clear, if something is not clear, please do feel free to leave a comment on the video, and I'm going to come to answer those questions as promptly as possible. And I will also encourage you to subscribe, because we have videos that cover the entire JAMB syllabus, so you can easily go to any topic they are struggling with and get a deeper understanding into how to approach problems of such nature. So thank you very much, and I'm going to see you in the third part, where we continue solving our JAMB Mathematics Past Question for 2022. Bye for now.